All right, the last part that we need to cover here, separate from the last chapter, which is chapter 3, this sort of stands alone. So we're going to focus a little bit more on parabolas. We just finished a chapter on parabolas, but now what we're going to go into is the conic part of it in terms of finding other stuff besides the vertex, axis of symmetry, y-intercept. Are they still important? Yes. It's just how we go about them is going to be different because there's going to be a special format as to how we write a parabola equation out. So, starting again, so we have a parabola is the set of all points in a plane that are the same distance, it's supposed to say away from the focus point and the directrix line. And the last one is the thing called the latest rectum, is the line segment through the focus of a parabola and perpendicular to the axis of symmetry. Now, the nice part is, location-wise, I'm not that concerned that you know where these things fall. Know that a focus is a point, directrix is a line. Those are the two key things, but you're going to be calculating. This is 100% algebraic in terms of what you're about to go over. But if you look at this picture right here, this is definitely showing you placement-wise where everything falls. The focus would be inside the parabola, the directrix would be behind the parabola. We already know the axis of symmetry splits the parabola in half. But the new thing that's coming into play is there's a standard format for parabolas. So you have two columns here. Column on the left is going to be for parabolas that open up or down. Column on the right is going to be for parabolas that open left or right, which we haven't really touched on yet. So for the parabolas that open up or down, let's look at the first column. So the format now that the parabolas are going to fall into would be this one right here. So y equals a parentheses x minus h squared plus k. So a bunch of important things to note. If a is greater than 0 or positive, then the parabola is going to open up. So you can draw a picture or just note that it's going to open up. If a is less than 0, then it's going to open down, or you can write opens down. Whatever way helps you understand what direction. The vertex of the parabola, so in the past we've had other ways of calculating it. Now what we're going to do is take the standard format equation and pull out the information. So the vertex is your h and your k value. The axis of symmetry is going to be x equals whatever your h value of the vertex is. The focus is a point, and the h value is going to be the same as the vertex. And then for k, or the second point, or the y value, you're going to do k plus 1 over 4a. And for the directrix, it's the same equation. For the focus, it's just subtraction. And then the difference is it's now a line. So keep in mind, a focus is a point, and the directrix is a line. And then honestly, we don't do this, so it's just for formality reasons. So I'm going to bounce back and forth here. So we're going to focus just on one type at a time here. So what we're going to do is we're going to jump to example number 1. And we're going to basically, what you do is you dissect and you identify everything. So I'm going to do one of each of these. So it says, write the equation in vertex form. We're going to identify the axis of symmetry, coordinates of the focus, and the equation of the directrix. So actually pause that. I'm going to go back and do the second column first because I just saw what I had to do from last year. All right, so column 1 is opening up or down. Column 2 is opening left or right. So if you try to compare the two of them, you're going to notice the x and the y flip places and the h and the k flip places. That's ultimately what happens. So if a is greater than 0, it's now going to open to the right-hand side in terms of the parabola. So you can draw this, or you can just draw an arrow. If it's less than 0 for a, it's going to open to the left. The vertex still remains the same. What changes now, though, given that we flip the x and the y and the h and the k, the axis of symmetry is now y equals k. The focus, we're now adding the 1 over 4a to the h value, And the same goes for the Directrix. We're now taking it away. So what I would suggest is keep this chart next to you as we go about the examples. So whether you rewrite the chart or whether you do the examples on a separate piece of paper, whatever you need to do, but keep this chart next to you because this is what you have to start studying now and start sort of memorizing because that's what you're going to be using to calculate all the information. All right, so the reason I went back and I went over the second column is because what I want to start with is B first, just so that you don't get confused. This may seem very confusing right now. The whole idea is I'm starting with this one because it doesn't have a number besides 1, or because it has a 1 in front of the y squared. So the first thing we do is we look at this problem and we say, okay, well, first of all, it's x equals y squared. So we know that this is a scenario where it's going to go right or left. So this is going to be column number 2 on our chart. The other thing that comes into play is because in order to write something in standard form, you're going to have to be using completing the square. So this is sort of everything now comes together. So if we are going to complete the square, what we need to do for a parabola now, it was different when we were just completing the square in general for quadratics, but for a parabola, we're going to put the two values that have y's in parentheses, and we're going to kick the 11, on the outside. Let me actually erase that. So we're going to kick the 11 on the outside. It's still negative, but it's not going to be part of the parentheses. So what we're going to do is we're going to set up our format for completing the square. So I'm going to leave a space in the parentheses. And then because with a parabola, everything has to be done on one side, I'm going to put the space on the other side of the 11. Again, you're not doing it to both sides of the equation. This is where the difference occurs from when we did completing the square in the past. So when we completed the square, if we recall, we need the b value, which comes in front of the y, which is -8. Half of b would then be -4. And then -4 squared would be 16. And that number we're going to add inside. Now, the other difference that comes into play is if we are adding it in the parentheses, given that everything is being done on one side of the equation, I can't add it in both locations because that just means I added 2 16s, which changes the whole value of the equation. So if I'm going to add it inside the parentheses, I need to subtract it outside of the parentheses. It needs to be the opposite operation of what you did inside. All right, so now if we look, we know that it's a perfect square. So we get y minus 4 squared minus 27. All right, so again, I'm following the same mentality that we did when we completed the square in the past. The only difference is we now have something that's being added or subtracted at the end. So if you look, this is in now standard form. So column 2 says x equals a, y minus k squared plus h. So a is 1, h is -27, and k, because it's supposed to be y minus k, it's y minus 4, so k is equal to 4. So you want to identify those three things so that when we go back and we have to figure out all the information that's asked of us, we have the values identified. So we're looking for vertex, axis of symmetry, coordinate of the focus, I can just write focus, and then the directrix. So we already wrote the equation in vertex form, so this is answer number 1. That's vertex form. All right, so we go back to column 2. So column 2 says, well, my vertex is h comma k. Well, given that I've already identified what my h and my k are, my vertex would then be -27, comma 4. Again, keep in mind, your vertex is h comma k. Your axis of symmetry for the second column would be y equals k. So that's y equals, and your k value is 4. For focus, the value that's on the chart, it's h plus 1 over 4a, comma k. So h is -27 plus 1 over 4 times 1, comma 4. You're going to have to get common denominators here. So this is negative 27 plus 1/4, comma 4. If you get common denominators, that is a 4. What you'll end up with is negative 107 over 4, comma 4 for the focus. The Directrix, the formula is x equals h minus 1 over 4a. So x equals negative 27 minus 1 over 4 times 1. So that's negative 27 minus a fourth. So you can either say x equals negative 27 and a fourth, or combine them, and you can do negative 109 over 4 for the Directrix. So there is a lot invested in each one of these questions. So again, the chart is so crucial because if you don't know placement-wise where things need to go, then that's going to throw everything off. And I'm telling you, everything gets impacted by just the vertex value. So that's the most important value to get. And in order to get that, you need to get the equation. All right, so let me see. So the reason I did not do the first example, the main reason is because there was a coefficient in front of the x value. So would it have been easier to start? Probably, but because there was a value in front, I couldn't have done that. So we had to wait. All right, so let's go back to this one now. So we're still identifying all the information. The only extra bit of information that happens here is when you have a number that's not a 1 in front of the variable that's being squared. I'm still going to put the values with the x's together, but this 1 is a problem. So what I need to do is take it out like a GCF. So I'm going to take a negative 1 out, but that also gets taken out of the 2x. It does not affect the 3 though. So it only comes out of the values that have variables with it. So now that negative 1 is just going to hang out outside for right now. And I'm going to set up my completing the square process with my parentheses. So I've got b is equal to, I'm only focusing on the parentheses. B is 2, so half of b is 1, and 1 squared equals 1. So I'm going to add 1 here. Now, with the last example, we added 16 and we subtracted 16. With this, you have to be careful, because if a number got pulled out, yes, I wrote a plus 1, but this is actually a negative 1 when you multiply. So if that is really a negative 1, then this needs to be a positive 1 on the outside. So lots of things that come into play when there is a leading coefficient there. All right, so let's write ourselves our perfect square. So we get y equals negative 1. We have our perfect square of x plus 1 squared plus 4. So then if I write my format underneath it, y equals a x minus h squared plus k. I need a, I need h, and I need k. So a is negative 1. H, it's supposed to be x minus h. So if it's x plus 1, that means it had to be an x minus a negative 1. So h is negative 1. And k is going to be equal to 4. So now we're going to find our information. So we need vertex, which is h comma k. Axis of symmetry, keep in mind we are looking at the first column now. X equals h. For the focus, it is now going to be h comma k plus 1 over 4a. And for the Directrix, it's going to be y equals k minus 1 over 4a. And that's all the information we have to calculate. So the vertex, we know our h and our k is negative 1, 4. Our axis of symmetry is x equals h, which would be x equals negative 1. Our focus would be h comma k plus 1 over 4 times a is negative 1. So that's negative 1 comma 4 minus a fourth, which would be negative 1, and then we have 15 fourths. If you want to make it 3 3/4, that's fine, either one. Directrix, we have then 4 minus 1 over 4 times negative 1, so that's 4 plus a fourth. So it's either 4 1/4 or 17 fourths.